Well, just 3 weeks ago, it was announced outside Chicago at Fermilab that we found a huge crack in the standard model, meaning that at low energies, the standard model of particles, subatomic particles, is slightly incorrect, meaning that there could be a fifth force out there. The four forces are gravity, light, electromagnetism, and the two nuclear forces. They rule the universe. We've looked for a fifth force and never found it. This could be the fifth force, unraveled just 3 weeks ago outside Chicago. This is big news.
Yeah, that's
It
huge
means
news.
that the standard model of quarks and neutrinos and electrons is incomplete. Therefore, we need a higher theory, a theory at higher energies, and that could be string theory. String theory predicts a new octave of subatomic particles. That's probably what we are finding now outside Chicago. So this is big news.
I mean,
The standard model has been held sway for 50 years.
Yeah, I was
It's
gonna
held
say.
sway, but now we find the first crack in the standard model of particles.
That actually happened right here in Austin, right? Steven Weinberg, and he was a professor at University of Texas, Austin, if I'm not mistaken. Yeah, that's
That's
been
right.
around
Nobel
for a very-
laureate, a big pusher of the super collider,
Yeah.
right?
Yeah, he's instrumental in having that happen. That's great. I haven't read anything about that yet, but I'm definitely going to look into that now. So what is there any supposition on what the new force might be? Is it?
Well, we think that it's going to be a new force, but forces are mediated by particles, like photons mediate electromagnetism.
Right.
So we think there's a new particle out there. And string theory has particles like the photino, which we think generate dark matter. Dark matter makes up most of the universe, in fact. It holds the galaxy together. We think that the photino could be dark matter, and we think something like the photino could be found in Chicago with the Fermi Laboratory, indicating a fifth force, a new force of nature being discovered right before our eyes.
Right. And there's a proposed particle for gravity as well called a graviton, right?
That's right.
Might be in some future generation used to communicate between one universe and another universe. I mean, there's a lot of weird shit going on there.
Tons. Let me ask you this. Why do you think there's so many critics of the string theory itself?
Well, first, it's too successful. It's so successful it's caused a backlash. People are jealous because it's draining funds away from other fields. But you have to realize that when I was a grad student, string theory was considered ridiculous. It was considered oddball, too strange. You couldn't get a job hardly being a string theorist. So this is the way science is done. There are fads and fancies in physics, and there's always a backlash when a theory becomes too successful. Now, there's a legitimate criticism of string theory, and that is there's no direct proof of the theory yet. That's why we're looking at the Chicago result very carefully. And dark matter, once we find dark matter in the laboratory, that could clinch it right there. The fact that the properties of dark matter could reveal the properties of string theory. So in my book, I lay out 5 different ways of testing string theory. But that's the main criticism, the fact that it's not directly testable at the present time.
And so, I mean, yeah, that's always going to be the issue. And a lot
The
of
challenge. And can you put a year on that? Like, how many years do you think that it would take? Because you mentioned Einstein in your book and, him not being able to finish. Do you think you'll be able to finish, or how long would this take? I mean, I know it's a wild answer, yeah.
Discovery
Or a question,
cannot
but-
be happening on demand, and however, I think we're in the right direction because we see now a crack in the standard model that we didn't have before, and dark matter experiments are going on right now. Once we find out what dark matter is, that could then immediately give us a test of string theory, because string theory predicts what dark matter is.